Hi everyone. In this video we will learn about gas laws. We started talking about gas earlier in the unit. We talked about the properties of gases and Dalton's law of partial pressure, kinetic molecular theory of gases. So it again starts with the review of kinetic molecular theory of gases, that gas particles are too small to take any space. Again, I told you, if you remember, that this kinetic molecular theory of gas is based on ideal gas, that they do not attract each other or repel each other. The gas particles are much smaller compared to the distance between them, so their volume is kind of negligible. Gas particles are in constant random motion and they have elastic collision. That is the most important postulate of kinetic theory. So knowing kinetic molecular theory of gases, we will move on and learn about gas laws. So there are different scientists who have predicted the behavior of gas, again assuming our ideal gas law. There are many variables. So we can, when we have a gas in the container, we can talk about the pressure of the gas, the volume of the gas. Like if we have gas particles in here, and if this lid is movable and I put a pressure on this gas, like I squeeze it in, as you know, there is a lot of space in between the particles. I can squeeze them down, so the volume will decrease. Okay, so one variable is pressure. Okay, the other variable is volume. All right, the other variable is temperature. So the kinetic energy of the gas particles will increase if I start heating it up. So if I start heating it up, let's assume that I ignore the pressure here. If I start heating it up, gas particles will move faster, and the faster they move, they will push this lid up. And if I seal it, the pressure inside can go so much that it can even burst. So you know that increasing the temperature increases the pressure if I don't let volume change, or if I let the volume change, then volume will increase. So, and the other variable is the number of moles of gas. Like how much gas do you have? So there are three variables. We represent this by N. N is the number of moles. So there are four variables here: pressure, volume, temperature, and number of moles. As I study as I teach you the different gas laws, out of the four variables, we are going to keep the two same. So in this law, we are going to keep the temperature and the number of moles constant. So both of them are not changing. So I assume that if number of moles don't change and if temperature doesn't change, then what happens to the pressure? As I just mentioned earlier on, if I increase the pressure on this lid, I can squeeze the volume down, and the volume will decrease. So as you see that this is an inverse relationship. So as you increase the pressure, the volume will decrease. So it's an inverse relationship. So pressure is, let me erase it. Pressure is inversely proportional to the volume. It's a seesaw relationship, if you know what a seesaw relationship is. So if it goes down, it goes up. If it comes down, this goes up. So it's a seesaw relationship. If one goes up, the other one goes down. So you see, if at less pressure, you have more volume. At a higher pressure, you have less volume. And you need to understand the kind of the curve it gets. This is the only way we represent the inverse relationship. So we have pressure and volume. With to remove the proportionality sign, we put a K, K over V. So P equals K over V, and then K equals P multiplied by V. So that means multiplication of pressure and volume, the product of pressure and volume is going to be constant. Where K is the constant. Okay, so let's talk about how do we solve the question. A sample of a helium gas in a balloon is compressed from 4 liters. So this is my pressure, volume 1, to this, I'm sorry, not the pressure, it's liters. So it's volume 1, this is volume 2. If the pressure of the gas in the 4-liter volume is 200 kPa, so for this one the pressure is P1, what will be the second pressure. So I need to calculate the P2. It tells you right here that the temperature is constant. Even if it doesn't tell me, there is no mentioning of the temperature, so I'm not going to be concerned about the temperature. All I'm going to do is plug the numbers in. My first pressure is 210, my first volume is 4.0. My second pressure, I don't know, this is what I'm calculating. This is my second volume. So to calculate the P2, I will take 210 multiplied by 4.0 divided by 2.5. Okay, that will give me the pressure 340 kPa. Okay, how do you know the unit? Whatever the unit of the pressure is here, that will be the unit for the second pressure. Both volumes got to be in the same unit, both pressures have to be in the same unit. So this is how we calculate the pressure and volume using the Boyle's law. So we need to understand, we need to be able to identify that which equation belongs to which scientist. So Boyle is the scientist who gave us the pressure-volume relationship at constant temperature and constant number of moles, and it is an inverse relationship. Okay, so the next one is called Charles' law. So we need to do these questions in the class. And then we have Charles' law. So Charles is a scientist who studied pressure and temperature. Okay, he studied pressure and temperature, and he said that at constant temperature, at constant pressure, so he's not changing the pressure, the only thing he is changing is the volume and temperature. So he's not changing the pressure, he's not changing the number of moles. So the two will stay same. So if we know this pretty well, that if I start heating up a gas, okay, this is a gas, if I start heating it up, it's a heat, the pressure inside will increase and will push the volume up. So if I don't want to let the pressure increase, I need to leave the lid loose so it can move up. So I know that the volume will go up, the volume will increase. So then that means that the temperature is directly proportional to the volume. So if temperature is directly proportional to the volume, when I bring the constant in, it becomes temperature over volume over temperature. Volume over temperature. V1 over T1 equals V2 over T2. So I have temperature on my x-axis and volume over y-axis. Okay, so V1 over T1 equals V2 over T2. You have to memorize that this is the Charles' law. Okay, so the temperature, you have to understand this. You have to always remember this, that for all gas law questions, okay, take these notes. For all gas law questions, you must use temperature in Kelvin scale. Okay, you can never use Celsius. We know 0 degrees Celsius is 273 degree Kelvin. So if I give you 10 degrees Celsius, that means you will add 273 to make it 283 Kelvin. So you will never use Celsius. Okay, you can only use Kelvin scale. Never use Celsius. So every time you are given a Celsius, you are going to add 273 to convert it into K. Okay, so keep that in mind. That every time you're given Celsius, you need to convert it into K before you plug it in. Alright, so if I go back, this temperature, a gas sample at 40 degrees Celsius. That means I need to add 273 to this. Occupies a volume. So this is T1, this is V1. If the temperature is raised to T2, again I have to add 273 to this. What will be the second volume? So my formula is V1 over T1 equals V2 over T2. But you see the T1 and T2, they both have to be converted into Kelvin scale before you plug it in. So once you convert it, you just cross multiply and that is your answer. So it is not hard once you plug the numbers in. So far I have given you two formulas. One is P1V1 equals P2V2, which is Boyle's law. The second one is V1 over T1 equals V2 over T2, that's Charles' law. And this one doesn't have any temperature, but since this has a temperature, the temperature got to be in Kelvin scale. So these are the two laws we have to understand. We will do these questions in the class. Then we have a Gay-Lussac's law. Gay-Lussac's law keeps the volume constant, and he says that if you increase the temperature, the pressure increases. And as I said, we have learned that before, that if we increase the temperature, the pressure increases. The gas particles move at a faster speed, the kinetic energy increases, so does the pressure increases. Okay, so he just gave us the same thing, same kind of a relationship, that the pressure is directly proportional to temperature. If I increase the temperature, pressure increases. So P1 over T1 equals P2 over T2. Volume is constant, number of moles are constant. All right, so we can again do the questions. Again, you will make sure that the temperature is in Kelvin scale. No, so I gave you three gas laws. P1 V1 equals P2 V2. I gave you V1 over T1 equals V2 over T2, and P1 over T1 equals P2 over T2. Your one goal is to make sure you know the name of the scientist, okay, who gave us these relationships. You need to know the graphs. So temperature and pressure, you have a straight line graph. Okay, temperature and volume, you have a straight line graph. And then pressure and volume, you have a parabolic graph. So once you know this, I want you to go ahead and mix these three together and come up with one common equation. Okay, if I mix all three of them together. If I mix them all together, I get P1 V1 over T1 equals P2 V2 over T2. Okay, and that's called combined gas law. Okay, combined gas law. So this is if you mix them all together. So if I take the temperature off, it becomes Boyle's law. If I take the volume off, it becomes Gay-Lussac's law. If I take the pressure off, it becomes the Charles law. So when I combine them together, it is called combined gas law. Again, a couple things to remember, that the temperature has to be in Kelvin scale. Okay, so convert the Celsius into Kelvin before you plug it in. The volume have to be in the same unit. It could be milliliters or liters, doesn't matter. And there are 3 units for the pressure. Okay, there are 3 units for the pressure: 1.00 atm, 101.3 kPa, and 760.0 millimeters of mercury. You have to memorize the 3 units of the pressure. So we will do this. This is the combined gas law equation. We will do all this practice in the class, and then that's it. We will talk about the Avogadro's law later on. Thank you.